So let's talk about how we can actually determine the equipment cost based on sizing and other factors from empirical formulas and also from tabulations. And I'm going to share with you a variety of these resources uh, through email and also on this particular PowerPoint. So since we've shown that equipment costs account for a large amount of capital cost investment, we probably need to be able to figure this out without calling vendors right away to get a quick and dirty understanding estimation of our operation. All right, you can get them from empirical equations, and the empirical equations typically follow the form here, where the cost in US dollars is going to be equal to some material factor, which is in the table, times E raised to some bunch of factors, where S here is the sizing factor. And each piece of equipment is going to have its own value. Your textbook will chart them all out, and I will show you. Aspen itself, which we'll see in a bit later, also has a way to approximate costs, and it keeps current with the current data trends. So every time we're using a more current version of Aspen, we will have a better approximation for our equipment costs. So if you're using a 1985 version of Aspen, it's going to be probably more true to the 1980s than it is to now. So you do need to upgrade Aspen for that feature. Okay, so let's look at pumps. So the material factor for pumps, again, is going to follow this equation here. So this F sub M is going to be, for different materials, going to have different value there. The S here, the S was going to be embedded in the LNs here, and is going to be the flow rate in gallons per minute times the head in feet square rooted. All right, and the coefficients A, B, and C for a centrifugal pump, for example, will be these. You can look up what it would be for other types of pumps as well. But if I put in these three values, this is a negative here, and I know the flow rate of my pump, and I know the head and everything like that, I can calculate its cost this way. So that's one way of doing that. The other way is to look at a graph, which, I mean, this doesn't look so specifically great, but if you have the capacity, which again is the flow rate, you can have it here in gallons per minute or in meters cubed per second. You can get your purchase cost, and this is true for January 2002, so be aware here. And this is specifically this is dependent on the type of pump. So this is for a cast iron case, iron alloy gears, steel shaft with no gear reducer. And this is, whatever, for specific types of pump, whatever you have. All right, so you have the option to do that through relations or through graph. Same thing for a fan. The sizing factor here is just going to be equal to my flow rate in cubic feet per minute. And A, B, and C will depend on the type of fan. So I'm giving you a bunch of fans here. And you can go and put that here, A, B, and C again. And my S will be just equal to my Q in cubic feet per minute. And you can get what you need. Again, graphically, you can look at that too. And if you, I give you here four different types of fans. And you just change the capacity and you can get what you want as far as the cost. Again, this is true for about 20 years ago, so be mindful of that. Heat exchangers, the sizing factor will depend on the area of the heat exchange, A, and their relation will change a little bit. And here is some relations you need to know. And then graphically, for a heat exchanger, again for 2002, you can get it from here, okay? And here's the empirical relation for a heat exchanger. It's not going to be the same as the equation I showed you before. It's going to look like this, because now I have to add F sub L depending on the length. And then the S is A, the area in feet squared. Fm again is the material factor, which you can look up, and is going to be equal to this. And I'm giving you everything you need in this chart here. So this is, again, these relations that I'm showing you are not based on any theoretical treatment. They're not based on anything at all like that. They're just approximations. So don't be alarmed if what you're getting is not true. You're just trying to get ballpark figures. And here's some sizing for other pieces of equipment. So the sizing factors for other pieces of equipment. So for storage vessels, for example, you would use this. For dryers, you'd use this surface area, and so on and so forth.